think we've got our group together, and those who join us late can catch up. Again, I want to thank everybody who has joined us and those who are coming in just as we start our webinar today to talk about a challenge that many of us are facing related to the supply chain. So I am Claire Swedberg. I am senior editor at RFID Journal, and I'm familiar with both Thin Air and Energous, having written about them in the past, and I'm delighted to be here today to help moderate as we have a conversation about digitizing the supply chain. So I have with me today, I'm going to start with Brian. We've got Brian, who is Merkling, CEO of Thin Air. We also have Gianpaolo Marino at Energous, and Cara Basilius, also of Energous, who are going to give us a sense of both what we can be doing today with wireless power and the Internet of Things, and the ways that problems are being solved in the supply chain. So I'm going to see if I can show you the agenda we have today. We're going to start with Brian talking about Thin Air and giving us a little explanation about the company and what they do. Same thing with Energous. We'll get a sense of what they do and the solutions that they're providing today. Then we get into the real nitty-gritty of the challenges of the supply chain, where we are today with that, and Energous's WPN topology for asset tracking. Thin Air can explain also the IoT platform and digitizing supply chains and the benefits. And we'll make sure we save some time for people to ask questions so we can target some of the areas that really interest people today and help us understand where we're going forward. So I believe, Brian, I'm going to turn this, well, actually, let me give you this one more slide. I'm not there yet. Energous is an advanced developer of, close this up, RF-based wireless power networks. For those of you who are not familiar with the company, you're about to learn a lot about it. Thin Air is an IoT SaaS, a software as a service platform, delivering solutions to remove waste from supply chains. So with that, I am going to turn it over to Brian, and let's hear a little bit about the supply chain and what Thin Air is doing to help support.
Thank you, Claire.
Yep.
So there's enough wrong with the supply chain. We've all, I think most of you have probably joined because of issues that you're likely having with your supply chain or some work that you're trying to do in the supply chain. So there are enough issues that we could break it down in multiple webinars. Today, we're going to talk about just the inefficiency of data capturing. In fact, there's still a lot of manual processes. It's still extremely siloed. So it's siloed across planning, order, and performance, predominantly because it's siloed across locations. So the ability to do or introduce IoT is usually a different vendor on the manufacturing floor. It's a different vendor at the distribution center in the warehouse, and yet still a third vendor or fourth vendor during the transportation phase of the supply chain. So a lot of silos cause a lot of manual processes and a lot of manual operations, which are based on the manual data capture. So a lot of issues across the supply chain. I want to talk a little bit about some of the things that we're doing. So we've introduced a new class of data across the supply chain. We've entered a period where technology has evolved across a number of technology areas. One, the cloud. So we're doing some really interesting things with Microsoft in the cloud at extreme scale. We're also doing some really interesting things with some of the world's largest access points companies like Aruba, like Juniper, like Cisco. But kind of the last piece or that last mile that we've been missing has been the edge. And Energous has brought some technology to us that has allowed us to do some new things at the edge that allow us to create the Internet of Everything, which is critical for removing some of these supply chain issues that we're talking about. So I talked a little bit about the platform. We've spent years and millions of dollars creating an agnostic platform. So agnostic from the device standpoint. And this is where the paradigm shift began for us. So There are new BLE sensors coming to market every day. And there's a new BLE sensor from a company called Wiliot, which we'll dive into later in this webinar. So Wiliot has brought a passive sticker that uses ambient energy to partially power itself. So if you take that, a low-cost passive BLE sticker, combine that with all of the other BLE devices or sensors that have come to market that can do anything from temperature to humidity, vibration, voltage. Now we're starting to get a bigger picture or a more complete picture of the supply chain. And we're starting to really bump up the values across the ROIs. Infrastructure's changed drastically as well. So we are agnostic across the access points, so Aruba, Cisco, Juniper. We're able to use those in a mesh, which I'll talk about in a second, but Energous has allowed us to do some new things with the passive technology that really enabled for us the Internet of Everything, which is key to the supply chain. And the Internet of Everything has to go more places than it went before. So there are new frontiers that we've never been able to push IoT, and one of them is into classified areas. So we have new classified solutions that we've enabled as well. Of course, you can't just do Wi-Fi, you've got to have 4G, 5G, and our platform handles all of that. We are tuned to Microsoft, but we can work on other clouds. The last piece of our platform is the ability to offer up all of this data at extreme scale. So we do have the world's largest IoT deployment. We capture millions of data points every second at every location. And then we do two things with all of this data. We push this data to a real-time message broker that feeds an application we call Sonar. It is a dashboard view, both table, graphs, map views. It's a range-based triggers and alerts engine and a resolution engine. And it's designed to democratize data. So when we say democratize data, we mean the most simple user in your environment or in your enterprise can use Sonar and can get business value out of it. The most advanced data scientists can use that real-time message broker and the API to feed your MES, to feed your ERP, feed your analytics systems. And then we've even built a lot of analytics right into the Sonar platform. So huge advancements in the cloud at the platform level. But at the infrastructure, and this will kind of set the stage for Energous discussion, we have what we call gateways. These are quad-core edge computers that we put out that sweep the air for active BLE signals. Critical to what we're doing being that these are low cost and very easy to deploy. So you've got this lightweight, very powerful infrastructure that goes far beyond what RFID could have done in the past. RFID is very limited in what it can capture in terms of distance, the type of data packets that can be exchanged from RFID tags. We're talking about tags that can feed us real-time vibration at 50,000 reads per second, or real-time ambient energy, temperature, humidity. We can do voltage. There's just so many things that we can start to do now because of these gateways. Then I've talked a little bit about the access points. So if you've got Aruba, Cisco, Juniper access points, as long as they're the right generation with the right capabilities, we can even mesh them in with what we're doing from an infrastructure standpoint. And then the last one that really enabled the Internet of Everything for us are the internet or the Energous bridges. So this is how we bump the energy in areas where we care about IoT use cases, where we care about bumping the energy of these Wiliot stickers so that they can contribute to these IoT use cases. All of these new edge devices then mesh together and create this overarching oversight for your enterprise. And this enterprise, as you saw on one of my earlier slides, extends beyond the manufacturing floor. It extends beyond the distribution center and the warehouse. It extends out now to the transportation side of the supply chain. So now we've got a new view of the operations we've never had. We've got this new class of data And this new class of data really enables a more powerful ROI. If you put an infrastructure in place to just do real-time locationing, you're limited to how powerful that ROI can be. But if that same infrastructure that does real-time locationing across your supply chain can also deliver digital twinning of your machines and safety oversight of your forklifts, can let you know when water exists in places it shouldn't exist, or light exists, or vibration exceeds a certain threshold. Now the ROIs start to get extremely powerful very, very quickly. And if you can do all of that at extreme scale, which we do, I mentioned we have the world's largest IoT deployment. Now you're into a new situation where you've got this new class of data. This new class of data drives better decisions. So we have millions of sensors. We have millions of data points every second at every location. We have tens of thousands of people utilizing this same data all at the same time. That's why we talk about this new generation of the supply chain, this new class of data, this new class of better business decisions, all delivered in real time. So that's who we are, what we're doing at Thin Air, and we do that, of course, with Energous. And I will turn it over to them to talk a little bit about what they're doing.
Thank you, Brian. Thank you very much. Yeah, super exciting to see how the platform works at Thin Air. So hi, everyone. My name is Gianpaolo. Thank you for joining this webinar with Thin Air. Myself and my colleague, Carol Basilius, will be introducing Energous, and also will be introducing to you, this new asset tracking solution that Brian has started to highlight. First of all, for those of you who are not familiar with Energous, we are a wireless powered network provider with focus on IoT. And this is the reason why we work very closely with Brian and the Thin Air team. Their focus is IoT, and we see that as a very strategic partnerships on both hands. Our goal and our mission is really to bring unlimited coverage and, of course, set increased data efficiency for different type of IoT markets. What we want to do really is enable sustainable IoT with more flexibility and really get information on more devices, right? I mean, we are talking about the transition from millions to billions of devices, but to get to the billions of devices, there are some fundamental things that need to change. And this is what we're doing, basically. It is very also important, to get certified, radio transmission all over the world. So our technology is fully approved and certified, safe to be deployed in an industrial and also commercial use. So again, our goal here is really work to unleash unlimited amount of power and increase, the numbers of edge devices, and bring also elements of AI. As we all know, edge device and edge computing is becoming a lot more predominant, and so in order to enable, processing at the edge, in order to enable basically sensing technology like the one Brian has mentioned, with embedded AI, there is going to be a need of more power. And this is what we do. Last but not least, we are also very environmental friendly. We obviously focus on sustainability. Our goal is to eliminate disposable battery and cables. I don't know if you guys know, but I'll give you a data point. There is about 28 billion disposable battery reaching landfill every year. And that's bad for our environment. So, our goal is to really, help eliminate most of those so that sensors and all these IoT devices, can operate off of our technology and be much more sustainable. Next. So this is what we see in terms of the current and also future IoT deployment challenges. Obviously, battery, as I mentioned, present a little bit of a challenge, disposable battery in these regards, because capacity obviously limits the new feature. Capacity of the battery, being a disposable battery, always limits the amount of power that the battery can deliver. Therefore, it limits the functionality of the IoT devices. They're toxic, and obviously they're reaching landfill, and this is not good for the environment. But they also present a cost aspect that is associated to it. The cost of replacing a battery, especially as we want to go from millions to billions of sensors, is going to be very high. So this is really limiting the ability to deploy more and more IoT devices, with disposable battery in the market. So, again, we see that as a barrier that we really want to eliminate. The same thing also with wires and cables. Again, this IoT devices that have wires and cables, they have limited or no mobility or flexibility. They have obviously high installation cost. I don't know if you guys know, but typically it costs about $500, per square foot to deploy, sensors, with cables in an industrial environment. That's pretty high, right? Considering the amount of sensors that customers they want to start to deploy. Obviously, there is location limitation. When you have cables, you can't really place your sensors anywhere you want, right? Because you're always limited by, the cable itself. Again, limited movement and also extended downtime. And last but not least is data overload, right? Today, we see that every edge device, every IoT device wants to have its own basically connection to the cloud, right? But now think of it, when we get into the billions of IoT devices and every single IoT device, it wants to stream data by itself into the cloud. It becomes very clumsy. So Energous, really helps to eliminate that clumsiness and streamline, that data in packets so that, we don't basically overload, the network. Next. So our markets of applications are fundamentally three right now. We looked at the first market to be end-to-end device tracking, which is basically the standard RFID market, where we're now taking this market to the next level, leveraging, Wiliot technology, which Carol is going to explain in few slides. And also partnering with Brian. The second market where we focus on it, it's basically electronic shelf labels and digital information display. Again, ESL today's or the one that you actually see in the stores are not going to be the ESL of the future, right? ESL of the future are going to have element of AI, are going to have cameras embedded into it, are going to have element of NFC that enables basically the consumer experience to check out at the shelf, are going to be able to detect whether or not a product has left the shelf right there where it has been purchased, right? So all these elements are going to basically increase, the power demand of the ESL itself. So disposable battery are not going to be good enough to power those ESL. Same with cables, right? If you now need to run cables to get this ESL power, the cost of basically running cables for every shelf, it's very, very high. So this is where our technology comes very handy in powering ESL devices, enabling basically these displays, to become smarter, yet, not having to utilize, the current battery infrastructure that is available today. And last but not least, IoT sensors. As Brian has mentioned, sensors are very, very important. The more sensor we deploy, the more data we're able to basically gather, right? So in that regards, our focus is to enable these sensors to be operating off of our technology. So eliminating batteries and making those sensors basically operating through basically our wireless technology, right? So in that regards, we work very closely with Sensirion on the CO2 sensors and also AMS OSRAM on spectral sensors, multi-gas, and others. So the goal with them is to really enable these sensors to be basically wirelessly powered. Next. So interoperability, very, very important as well. Again, you are probably familiar with the different way of doing wireless charging. Typically, you look at NFC or Qi protocols, and the difference between Energous and these conventional way to do wireless charging is basically distance, right? When you talk about Qi or when we talk about NFC, we're talking about millimeters, maybe centimeters, right? When we talk about Energous, which is basically pushing power over distance, we're talking meters, right? So our goal is to extend, the power range of our technology and really reach, tens of meters to power up devices. In these regards, we work very closely with the Airfield Alliance, where we have created a standard with them, which is basically, power over distance. Next. So I mentioned at the beginning some of the challenges that we see in asset tracking today. Tag readability. Again, with standard RFID devices, passive RFID devices, you're never going to be able to get 100% readability. You're never going to reach basically a full reading range of the tag. Also, the total cost of ownership is very high. I mean, it takes a lot of capital expense to really develop these infrastructure that will sustain our RFID. We see limited sensing capability, right? So temperature and position is not enough anymore. We need more. Customers need more as they want to digitize, their operation, as they want to create a digital twin of their supply chain, right? So again, we need more data. And last but not least is sustainability, right? The elimination of disposable battery, which is not something that is very environmental friendly. Next. So again, the solution is really to focus on revolutionizing asset tracking. And how we do that? I mean, we do that with Energous, with thin air, leveraging multiple technology, sensing technology, Wiliot technology. The goal here is to really expand coverage to make sure that now we can cover largest area. We can connect more and more devices, reducing cost. Really, cost of the infrastructure that we're deploying, it's much less compared to the standard RFID infrastructure cost. Enabling customers to basically get a lot more information, temperature, humidity, positioning, right? And of course, the last one is elimination of disposable battery. Next. So having said that, I'm going to pass this on to Carol, who is going to explain you guys how the technology works, and he's going to get into more details. Thanks, Carol.
Thanks, Gianpaolo.
Actually, yeah, Gianpaolo, and let me just interrupt just for a minute. Thank you for your presentation. That was quite interesting. And Carol, it'll be great to have you jump in. Just wanted to remind everybody that we are open to hearing your questions. So please feel free to use the Q&A box or chat, either one, and we'll track those for the future. But there's one super important question that you guys can address as we go along, because I know I hear it all the time as a journalist too, is the status. All of this sounds so fabulous. Where are we actually right now when it comes to these deployments? And we'll talk some about that, but Carol, take it away. Thank you.
Thanks, Claire. And hello, everyone. I'm here to explain to you how the technology works in a little bit more details. First, to answer your question, Claire, I think the technology is today being deployed in the thousands of units. We are in production, and we have helped multiple customers today improve their processes in managing their warehouse and in also manufacturing facilities. And I'll explain how the technology can be deployed and implemented in different sectors. So the technology, the wireless power network, consists of multiple components. The major two components is the pixel, or what we call the RF tag. So the RF tag that we partner with Wiliot to create has embedded Bluetooth low energy transceiver built on the tag. And this is the first Bluetooth low energy batteryless tag that can adhere on the stocks to track the merchandise in a warehouse or an inventory environment. So the tag comes equipped with Bluetooth low energy. It gets energized using our power bridge. Our power bridge sends RF pulses over the air to energize the tags. Again, as we mentioned, keep in mind the tags is completely batteryless. So as the tag gets energized, the Bluetooth low energy transceivers wakes up, it sends a beacon. And the beacon contains a unique identifier information as well as the sensor information. And we're using temperature sensors. So we're tracking not just a unique identifier, so we're not just tracking the asset, we're also sensing environmental parameter within the environment. Next. And again, I think this is a block diagram of how the overall system, our power bridge, and again, this is the power bridge, this is Energous power bridge, and this is how we send energy over the air to energize the tags. And just to give you guys a reference, Here is an image of how the tag looks like. And this is a double sticky tape on the back, and these are the harvesting antenna and the communication antenna on the back of the inlay. So the energy, the power bridge, the Energous 1 watt power bridge, send the energy over the air. It energizes the tags wakes up, and it sends its unique identifier so we can record it to the cloud. The communication range is about 15 meters between the transmitter to the receiver. So we can reach a distance up to 15 meters between the transmitter and the receiver. And right now, how do we get these data from the asset we're tracking all the way to the cloud? So the infrastructure in place consists of having power bridge covering the warehouse environment that we're tracking. We also, once we send the energy to the tags wakes up and sends a very faint beacon or signal back to the power bridge. The power bridge receives the signal and then rebroadcast the signal at a much higher level. And once the signal rebroadcasted, thin air gateway can take the message, can receive the message, and send it to the cloud. In addition to powering a Wiliot tag or an asset tracking tag, as Gianpaolo highlighted earlier, we can also energize different type of sensors in the same environment, such as CO2 sensor, such as light sensor, environmental parameter sensor, as well as ESL or electronic shelf labels. Once the data is in the cloud, it can be accessed using an MQTT broker, and the thin air platform can also have access to the information. Again, this is the key parameter or the key features of the 1 watt transmitter. We're sending energy over sub 1 gigahertz to energize the tags. We're receiving data from the tag over Bluetooth 2.4 gigahertz. We have embedded antenna in the power bridge that can cover up to 15 meters, as I mentioned. Next. Next. So we believe this wireless power technology or sending technology over the air to energize these tags is a robust solution. It's a relatively inexpensive technology, as we mentioned, relative to RFID. It's easier to deploy because we depend on from a communication point of view on Bluetooth low energy, which is a universal wireless protocol. Most of our phones and mobile devices use Bluetooth, and the cost of infrastructure is much lower than RFID. We also using not just just sending data or unique identifiers, we're also sensing the environmental parameters. From a regulatory standpoint, we have a regulatory team in-house. Our products or our power bridges are certified across the globe. So we have certification, FCC certification, CE certification across Asia Pacific, and Australia and China as well. In-house, we pay a lot of attention to safety, and we have invested in SAR products. So we do specific absorption rates in-house tests, and just to highlight the SAR tests focus on measuring the energy absorbed by the human skin, and we comply with all the standards, and the product is safe, and as a matter of fact, it's safer than having a phone close by to the human skin. Next. These are some examples of how the system from hardware perspective can be deployed. So this is an example of a warehouse area where we're tracking about 60 pallets in the environment. So we require for such an environment to ensure we understand the layout of and the floor plan of the environment, the critical areas such as entries and hallways where the product is going to be moved or expected to be, and then we install our products or our power bridges in these critical areas so we can start the tracking, as well as tracking the product while in transit. Next. This is another example where the whole, not just the pixel tags or the Williot pixel tags are being used. This is an example where we deployed the pixel tags for tracking, for asset tracking, as well as sensors in the environment, so we can track the environmental parameter and ensure the products are being transported in a safe environment. Thank you.
Thank you, Caro. That's quite interesting. I wonder, just a quick question that comes to my mind is there any kind of limitation to how many sensors or tags you could actually be, using and accessing in this way? Is there any kind of limitations?
So that's a great question, Claire. Thank you for that. This is an RF tag. So as long as the tag within the range of the power bridge or the transmitter, again, as we mentioned, the power bridge sends energy over the air, and this energy can transmit or can reach a range up to 15 meters. So as long as the tag within the operation or in the range of coverage of the power bridge, we will track it. So there is we can track up to thousands of these tags within the range of the power bridge.
Okay. And do you have deployments like that already in place? That I know, again, everybody's interested in what's out there already. And there's certainly, I know Thin Air has customers and Energous has lots of customers doing something like this. How long has this actually been in place for a lot of your customers?
Brian, maybe you might want to take that. Brian, you're on mute.
So from the Thin Air side, we've had the world's largest deployment of IoT, which includes everything we've talked about on this webinar, and it's been live in production for more than 2 years.
Brian, is it possible to share? I know certainly we can't talk about the details of a customer, but what would it look like if you were able to give me a tour and we could actually look on site and say, this is what they are accomplishing, and with a typical customer and the kind of data they're picking up, that really makes this unique as opposed to, say an RFID deployment or something else.
Yeah, so we talked a little bit, I think both companies talked a little bit about the coverage difference over RFID. So we do have the ability, we cover, I think 30 feet distance from, and that's our conservative deployments. We cover a 30-foot radius around any bridge. So we put those bridges out in a mesh deployment instead of the old RFID, right next to each other, thousands and thousands of these readers. You don't need that many readers. You can spread them out farther. So that's one of the things that makes it unique. The second thing that makes it unique is that it contributes to an overall BLE mesh that we've laid out. So we are capturing certainly locationing. And so if you looked in on one of our installations, you would see real-time locationing, even trilateration of these passive stickers. So not just checkpoints or choke points like the old RFID deployments, but we'll actually trilaterate in an open environment where these stickers are. The fallback is closest to this bridge, but because of the mesh, you've still got a pretty good locationing. But that's combined with the health of a machine so think about these stickers put on a piece of raw material, and that raw material, we track the environment around it, the temperature, humidity, we track the real-time location. We know how long it sat on one machine. We know the health of that machine while it was on that machine. vibration, the engine or the motor temperatures of that machine, the angles of arms. So now we're taking quality control to a whole new level. We're also capturing manufacturing issues far sooner in the manufacturing process, because we can watch as they go from one machine to another. We can watch the path that they take. We can get into process improvement. We can understand how long they stay in curing environments. So not only are you seeing the locationing benefits, but you're seeing all of the surrounding IoT data that goes along with it. And then we at Thin Air even capture human feedback. So now you've got human input, you've got machine input, you've got location input. It's a new class of oversight that's never existed before.
Okay, yeah, thank you. And we just have a few minutes, and I'm gonna we have some good questions here, so we'll run through those really quick. But just one thing I was wondering if you guys wanted to comment at all on secure sites. I know it was kind of interesting for me previously to hear about this when it comes to the IoT and data being captured and then being managed when it enters an area, a very secure area, how you guys are accomplishing that.
Yeah, we can certainly talk about that. So Energous is key for what we do there. They've got the ability to put energy out, what we would call omnidirectional, or kind of around their devices, but they also have the ability to do highly directional energy. And we combine those two capabilities to ensure that in an open general area where IoT use cases are allowed, we will track these little passive stickers that we've been talking about, these Williot stickers. We will use the highly directional energy to ensure that we burst them and get them to broadcast prior to entering a classified area. And then we've invented what we call gateway or barrier gateways that will use AI to learn what signals should be around them and then alert you if new signals approach a classified area. So you combine all of those capabilities and we give you the ability to tag things that are bound eventually for a classified or a secret area. And you can do full, complete IoT use cases in general areas, but you can be assured you're not going to violate any classified rules or any government rules once they enter a classified area.
Okay, interesting. Okay. Yeah, thank you, Brian. And let me look at some questions that we have from the audience, because we have some good ones here. Let me just start at the top. We talked a little bit about the status. Here's a question. What are typical barriers to adoption that you've seen with your customers? What are your customers telling you that have been real barriers for them up to now?
Well,
Brian, I'll let you take that. I'll let you take that because you're closer to our customers.
All right. Yeah, I don't want to hog the Q&A, but so the barriers to entry that we've seen in the past have been cost. And so the changes that we've seen are the ability to introduce passive BLE technology into the infrastructure has drastically changed the cost. One, the sticker is much less expensive. So you're starting at $2, maybe $1.50, and they're heading to the sub 50-cent range. So cost has changed dramatically. The cost of the Energous bridges is exponentially less than RFID has been in the past with better coverage. So it's changed the cost there. And then I think we mentioned battery a couple of times. So we do have customers who have hundreds of thousands of active battery powered beacons. It's one thing to change 10 batteries in beacons across your enterprise. It's another thing to change 5,000. Hundreds of thousands of batteries become certainly a cost or a barrier to entry. So everything we can drive to this ambient energy that Energous is helping bring to the market will help all of the IoT use cases and the barriers to entry. Okay,
thank you. Yeah, I have another question that's sort of a follow-up, and this can be for either party here, all three of you, but this was somebody asked about AI and automation. And the world is changing, right? And there's so much we can do with AI, and of course, people are automating. So how do you see that shaping this solution and the supply chain in general?
Yeah, I can jump in and then they can.
Sure.
layer in. But from an AI standpoint, what we see is people are getting a little ahead of themselves with AI. So yes, AI is extremely powerful. It is already impacting the supply chain. AI and the models that you build depend on the data. And historically, the data has been siloed. We talk about that. So you've had disparate data across the distribution center, the manufacturing floor, and then the transportation phase of the supply chain. But it's also been very limited, location only. So we're starting to see location combined with temperature, with humidity, with fall detection, vibration. So all of these things are going to be important and are important to the level that the AI models can reach in terms of intelligence and how fast they can learn. The last piece that we're seeing from an AI standpoint, we can accelerate the models drastically by interjecting human input to accelerate the learning of the models.
Yeah, interesting. Okay, and here's actually, did anybody in Energous want to comment as well on that subject before we move on?
I think Brian has done a good job explaining AI and trends in AI. What I can say, what we see also is AI for preventative and maintenance. So in that regards, we're working a lot. We're working with some companies that are focusing on building AI models around sensors, specifically for that. So yeah, there is obviously an alignment between us and them, and into these preventative and maintenance, I would say, use case. So we're aware, and we're working proactively. Let me put it this way.
Great. Yeah, thank you. Okay, let me ask you a question about money. And it's what it all comes down to eventually for everybody is cost. You've talked a little bit about, obviously, there have been barriers as far as cost for other traditional systems. How can you explain exactly what your cost savings might be? Is there a way to put some kind of our heads around what that cost savings might be?
Yeah, the cost savings, especially if you're expanding beyond simple locationing, but if you can combine real-time locationing with digital twinning of your machines, with process improvement, we have a customer that's already had a $30 million ROI across 36 months. So huge savings. The cost of entry has changed so drastically as well. We've just introduced, and Energous is part of this, but we've just introduced starter kits that are less than $10,000, usually even less than $5,000. So you can actually start a real live IoT use case in minutes and hours for less than $5K now. Huge change over the way it used to be.
Okay.
And maybe I can add, we have run a case scenario with IDT, specifically focusing on vertical farming, control agriculture, where Energous, will come in to enable sensors, in particular CO2 sensor and spectral light sensors, which are widely used, for this type of application to be deployed without batteries and cables. And we have basically concluded that our technology can basically provide about a 47% cost saving over 3 years, which is huge. So it's a good value proposition to have, and it's a good discussion to have as you go in front of customers, right? Because you're going to save money, and you're going to save them money. So
yeah, very good. Thank you. Okay, well, let me throw another question at you here. This one, let's see. Should one of these deployments gain traction in the marketplace, who would manufacture the scores of pixels and power bridges needed for a large scale operation?
okay.
Yeah, go ahead.
I'll take that. So from an operation standpoint, today, we can. I'm talking for Wiliot stickers or pixel. There is the capability today to manufacture hundreds of millions. Okay, and there is different tag suppliers right now in the world that are already manufacturing, these pixel, and we work very closely with each one of them. So from a scalability standpoint, there's no issue in terms of quantity. As far as the power bridges is concerned, we today we are basically offsetting our operation from in-house to offshore to a very, very important CM, which is the same CM that manufacture for Cisco, Meriaki, Aruba. So we can go into hundreds of thousands to the millions of bridges very, very quickly. So for us, scale is not an issue.
Okay, that's great. That I think you've answered that question. So I'll move on here. Let's see. Is there an up-to-date list of sensor products which can be powered wirelessly by Energous right now that someone could access? That would be helpful to identify possible applications. Is there such a thing?
Yeah, I mean, right now we have started, as I mentioned in my presentation, Sensirion, we're focusing with Sensirion on CO2 sensors. CO2 primarily are used in HVAC application to improve, the efficiency level of HVAC solution. But CO2 today are also used in smart building, are used in smart warehousing, livestock. So this is obviously a sensor that it's very important because it's a standalone sensor. That sensor does not require integration with other sensing technology. Okay. And the second one, it's basically spectral light sensing, which is basically the partnership that we have ongoing with AMS Osram. Spectral light is very important in controlled agricultural environments because you're sensing the light that comes from the LED. And then based on the light, you're basically regulating the light so that you're providing maximum growth for the plant. So these are the two sensors that we're focusing on. It. There is more in the work. We're also partnering with another company which does flow sensing, which is an interesting application. But again, we're just at the beginning right now. I don't want to expand too much until we know more details.
Okay, more to come.
Yeah,
Yes.
in addition, also we have integrated our technology with the IMU sensor. So we have announced a partnership in the past with Catapult, which uses motion to track activity in a sports environment for athletes. So we can integrate the technology with virtually different type of sensors. Just we're focusing on low power applications and sensors that make sense in the environment that we're supporting.
Very good, thank you. Okay, I have a question from industry analyst Dinesh Kithani. So he's great presentation. He says, understanding your technology is well integrated with different communication technology, which is vital for adoption. Can you elaborate with maybe a use case of how Energous solution not only powers IoT devices, but monitors and shares data both ways and delivers more?
Yeah, so go ahead.
No, go ahead, Carol, you take that.
So maybe I'll take this one. So the power bridge, as we mentioned, it sends the energy to energize the sensor and sends the energy over the air. And the not just energy, there is also, as we mentioned, a universal wireless a Bluetooth link that sends the data both ways from the bridge to the sensor and vice versa. So in most cases, we are sending the data on both ways, depending on the application and the environment.
Yeah, and maybe I can add, so Dinesh, we've done in retail IoT 2 deployments with Academy brand in Australia, and this is basically a use case where beyond just providing energy, we were also collecting data and then sending these data packets into the cloud to be basically processed by a cloud platform. So that's the Academy brand is probably a good example for this use case.
Great, thank you. One other question is about the future. So what I think you've kind of addressed some of the future plans and what the technology will be doing next. But did you want to both of you comment at all? Well, all three of you actually comment on what you're preparing for, emerging trends, and how you're going to be keeping up with all of the changes ahead.
I can hit it from the thin air side. We're already down the road we've prepared our platform to be able to ingest more data from passively powered beacons. As more and more come to market, we want to be ready for them, so that we've talked a little bit about removing batteries from the landscape, and we've already prepared our platform to be able to do that. So we think that's the biggest opportunity with the sensors that are available across the world, is to just start to remove the batteries from them. Well, all of the use cases are there, whether it's temperature, humidity, vibration, light, angles, XYZ coordinates, they're all there. We just need them to now be passively energized so that we can utilize this network that we're already building out with Energous.
Thanks, Brian. Yes, and from Energous standpoint, I would say that actually Brian mentioned we have introduced to the market an omnidirectional solution, which is different from the linear polarized solution that we had before. So now we have both to really complete all use cases. Again, that Thin Air wants to focus on it in an open environment or in a closed environment. We're also increasing the power level of our bridges. We actually announced last quarter our 2 watt power bridges. That is going to hit the market probably in the later part of this year. So again, we're increasing the power level to enable to provide more energy, more power, and to energize more devices. But at the same time, we are also adding a unique feature, within the power bridges that can again help customers, where there continues demand, right? So, and I'm not going to dwell, into the details of this feature. Maybe Carol, you might want to add, few interesting features that we're adding to our power bridges. But again, we're keeping up with the customer demand as we get more and more feedback now from customers. Then we're adjusting to change basically our roadmap and to include this unique feature that customers are looking for.
Absolutely, and we're easing the integration effort. So we're looking at every component from an architecture point of view, every hardware component, and we're trying to consolidate some of these components to eliminate the redundancies based on the experience that we have had in the past with Thin Air and our partners from a deployment perspective. So as we continue our effort, there is going to be more consolidation from a hardware. The solution is going to continue to be improved from an efficiency standpoint.
Very good. Thank you. I think we have time for one more question, which is kind of referring back to some of the conversation you had earlier in the Q&A about the pixels. We started throwing that name around, and people should probably understand what exactly a pixel is and its role. So I'll let you guys help out with that.
Yeah, so it's funny because we call these different nomenclature, right? For Brian calls those stickers, we call them pixel, but in reality what that is basically a very low power BLE tag that has been used by us and Thin Air to drive some of the important use cases that we just discussed in this webinar. Maybe Carol, you can show what that BLE tag looks like. That's basically what the pixel is. This is what we're referring to the pixel or the sticker, right? You can see in the back there is a Bluetooth low power chip with an antenna that is capable of harvesting energy. In this particular case is Energous energy, and enable basically this pixel to provide data into the cloud that is relevant to temperature, humidity, positioning, and all this good stuff.
Yeah, thank you. Is it? I think we did have a slide that showed the pixel. I don't know if we can pull that back up or not.
Yeah.
May not be something we can do right now. Oh,
there you go. There you go. Yes, that's the pixel. And think of these as basically next generation RFID, right? This is really what's going beyond, where is the technology moving, from, a passive RFID to a tag or a pixel or a sticker that it's actually much more that can enable data on the fly, right? This is something that you don't need to interrogate. This is a pixel that can provide you data constantly, and that data, as we mentioned, is temperature for now, humidity, and also positioning.
Very good. Okay, I think we have reached close to our time limit here, and we have, I think, done a great job of describing where we are going today with this technology and what's still ahead. So I want to thank all of my presenters here. So Kiro, Brian, and Gianpaolo, thank you so much. Learned a lot today. And we still have the question section open. We are recording this event. So we look forward to hearing from those who were able to see it, and look forward to future webinars ahead.